Okay, so we'll start off just by modifying the diagram a little and marking the centres of mass of the three relevant parts. For the rectangle on the bottom, the centre of mass will obviously be at 0, minus x, and then I note that the radius of the semicircles is 3, and that will allow me to write down where their centres of mass are. Now I'm using the formula given at the top, 4r over 3 pi, to find the how high up the centre of mass is, i.e. the y coordinate, and if I put 3 into that formula, you should see I'll simply get 4 over pi. So for the two semicircles, one will have a centre of mass at minus 3, 4 over pi, and the other one at 3, 4 over pi, as shown. The next thing that I'm going to do is I'm going to work out the relative masses or weights of these three pieces, and then of the composite piece, i.e. when I put it all together. And if I kind of think in my mind that W is the weight per unit area, I can see that the weight of the pieces, or at least the ratio of the weight, is the same as the ratio of the areas, and really that's always the case in questions like this. Okay, so I'm going to have a look at the weight ratios. And I'm just saying here that it's going to be the same as the area ratios. So I'm going to draw down the bits I'm interested in and then put them all together for my overall shape. First one is a semicircle, the second one is a semicircle, and of course the radius of the semicircles is 3, so just using pi r squared, the full circle would have an area of 9 pi, a semicircle therefore 9 pi over 2. For the rectangle it's just 2x by 12, so 24x, and then for the whole shape just add all that together and you should see you get 24x plus 9 pi. Now when I'm working, if I can avoid having fractions in my later working, I will do so, so I'd multiply throughout by 2 here to give me, sorry I have to sit down, 9 pi to 9 pi to 48x to 48x plus 18 pi, and now I'm just going to take moments. Now this equation is absolutely standard if I choose to work in this fashion. I'm going to pause it in a second just so we can see how it's built up. Okay, and so if we have a good look at that, it should be very familiar indeed. Now in fact in this question I am not going to bother working out the x coordinate for the centre of mass because I can see it lies on the line of symmetry of the shape anyway. Okay, so let's see what happens writing this out. Okay, I've done some working out as I've been going through here. Let me just pause it there to make sure we're happy. So the first one I did 9 pi times 4 over pi. The pi's cancel out and I'm left with just 9 fourths, which were 36. Same for the second part. For the next part I'd get minus 48x squared, and then on the right hand side I've got what you see. And then I'm going to divide throughout by 6 just to get the numbers a little bit smaller. And now I'm just going to bring all that together and I've got y bar. Now in the exam at that point in time I've really got all of the marks here, perhaps less one because I haven't written it in the format that they asked for. Okay, so let's just process this down and see how they've arrived at their answer. First of all, I'm going to simply pull a factor of 4 out of the top, but then I notice the following, and perhaps this is the part that does take a little thought. My y bar at the moment could be either positive or negative because it is the y coordinate of the centre of mass, but the question actually asks just for the distance. So how can I ensure that this will always give me the distance as opposed to giving me the y coordinate, which can be negative, whereas the distance is quite literally the positive the positive value only? And the answer is I simply take the modulus of this. Now if you look at it, 4 is always positive, so there's no point putting the modulus sign around the 4, and likewise the denominator is always going to be positive. In this case x has to be a positive value, so there's no point putting the modulus sign there. So in fact what I can do, I could have put a modulus sign around the whole thing and then just simplified it down, but with a bit of thought I can see that I could write it down like this, and then what I can then do so the answer looks the same as on the exam paper, is the modulus of 3 minus 2x squared is exactly the same as the modulus of 2x squared minus 3. They're interchangeable, it makes no difference. Put some values of x in just to test that if you like, but you'll see that I can also write this down like this. Whoops, it's gone a little bit far. Hang on a second, let me just rewind. Okay, and so we've answered the first part, and that would get us indeed full marks. Okay, on to part B of the question. So for this part I'm going to start off and just use the information they gave, and that was that x was equal to 2, and that will allow me now to find out that y bar is actually going to be equal to minus 20 over 16 plus 3 pi. So back to the diagram as shown here, and I'm just going to start to mark on now where the centre of mass is. I notice that in this particular problem the centre of mass has a negative y coordinate, but if I mark things up like shown, I'm just going to put it down as 20 over 16 plus 3 pi here. I've marked it down as distance. I'm then going to suspend this from the point P as shown and label that as the downward vertical, and I can see the angle there, alpha, would be the angle made with the downward vertical. Now the question actually asks for the angle made with the horizontal, and there are a couple of things you could do here. You could find the angle made with the downward vertical and then realise, of course, that the vertical and the horizontal are always perpendicular to each other, so you could do 90 degrees minus alpha in order to get the final answer. However, if you look at the triangle, then the angle which is 90 minus alpha is that angle there that I've just marked, theta. That makes the problem a little bit easier to work through, so I'm going to concentrate on finding the angle theta, knowing that that will be the angle that PQ makes with the downward horizontal for the reasons I just mentioned. So here we go, let's put some values on. That distance there will now be, if you think about it, for the total height of the rectangle less the 20 over 16 plus 3 pi we found earlier. I'm going to do a little breakout arrow to the side just to tidy up my working, and that would give me the following. And you'll see what I've done there, just subtracted 20 over 16 plus 3 pi from 4, so I need to get the same denominator, so I essentially had 4 times 16 plus 4 times 3 pi minus 20 all over 16 plus 3 pi, which simplifies down as shown, and then we can start. Now the tan of theta is equal to opposite over adjacent, so 6 over 44 plus 12 pi over 16 plus 3 pi, but I prefer to think about it as rather than 6 divided by that, 6 times by its reciprocal in the normal way that we would divide by a fraction. And then the rest of this problem is very, very straightforward. It's just a little bit of simplification, so cancel out a factor of 2 from the numerator and the denominator to give us this. Expand the bracket out as a last stage, and you will see that we get the answer that we desired. Okay, review through the problem carefully, actually work through the problem yourself. It's a very standard problem, and the technique that I've used here I would use every single time, and apart from the algebra in this, the actual method is very, very easy just to run through, to think about, to learn and to apply in the exam.